Okay, part 2, lecture 2, page 3, quadrature of the polygon. We are going to start, as usual, with an arbitrary polygon. So start with an arbitrary polygon. Okay, let me draw one. That's better. Okay, so I have some arbitrary five-sided polygon. Okay, let me talk a little bit about the total area of this polygon. So the total area of this five-sided polygon of the polygon is A plus B plus C. Let me tell you what I mean by A plus B plus C. I am triangulating this polygon, so I'm dividing this polygon into triangles. So here's a triangle, and here's another triangle. So I'm calling this triangle not good. What's this? I'm calling this triangle A. This is triangle B, and this other one is triangle C. So the total area of this polygon is the sum of the areas of these triangles that the polygon is made of. All I did is triangulated the polygon. So by the previous step, we know that triangles are quadruple. So what we're going to do is construct squares with sides A, B, and C, and little a, little b, little c, and areas big A, big B, big C. So let me just write it down. So by previous step, we know that triangles are quadruple. That means that I can construct squares with area A, square with area B, and square with area C, and that's exactly what we're going to do next. So by previous step, we know that triangles are quadruple, so we can construct squares with sides little a, little b, little c, and areas big A, big B, and C. Okay, so I'm going to draw them here. Let's see. So let's say this is square with area A. So this is area A. Meaning the same area as this triangle. Okay, I'm going to construct the other square B. Okay. Okay, so area B, and side B, and this is area B. That means it's the same area as the middle triangle. And let's say we have constructed the larger square with area C. Okay. So side C, and this is square with area C, which is the same, let's say, same area as this big triangle. Okay, so next we are going to construct right triangles. So next step, we are going to construct a right triangle with legs of length A and B, and hypotenuse is of some length x, and hypotenuse is some length x, where x squared obviously would be equal to a squared plus b squared. So let me just try to construct that. So length a this is length A, this would be length B, okay. And this is some length x. I don't know what that x is, but it doesn't matter. So I have a right triangle, length A and B, and this is of length x. And since it is a right triangle, by Pythagorean theorem, we know that x squared is equal to a squared plus b squared. Then construct another right triangle, then construct another right triangle. This triangle would be with sides x and c and hypotenuse and hypotenuse. Of some length y. Okay, so x would be one of the legs, this length would be the other, and hypotenuse would be some length y. I don't know what it is. 3, 1, 2, 3, 4, 5, 6, 7, 8. Okay. Let me just measure it. Okay. So let's say this is length C and this is a right angle again. So hypotenuse would be of some length y. Again, don't know what it is. Where obviously y squared would be equal to x squared plus c squared, again by Pythagorean theorem. So finally we are going to construct, we construct a square of side y. We construct a square of side y. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Let's say this is it. So here's the square of side y. Okay, so we have what? So we have y squared, I know it from before, it is equal to x squared plus c squared, but x squared is equal to a squared plus b squared. So a squared, instead of x, I'm going to write whatever x squared is equal to, a squared plus b squared plus c squared. And a squared plus b squared plus c squared is nothing other than big area A, big area B, big area C. Since these are squares, A plus B plus C. So I was able to construct a square with the same side as my polygon. So the point here was to show that the area of this rectangle is A plus B plus C, and that is the same as the area of the polygon. So given any arbitrary polygon, it is possible to construct a square with the same area. Therefore the polygon is squarable. Hence the polygon is squarable or quadrable. Okay, so that is the end of part 2. I'll move on to part 3.